Okay, hello. This is a presentation taking you through the coordinate geometry homework solutions. We're going to work through them together and hopefully you'll find where you were going wrong if you did make any mistakes. Okay, so what are the key ideas of this homework? Really, gradient, distance, midpoint. I can quickly write down the formulas for you actually for all of these. If you've got x1, y1, and x2, y2. This is what the whole homework's going to be based on, I'm certain of it. Gradient is just going to be y2 minus y1 over x2 minus x1. Can I point out that you can do it the other way around, but just as long as you're consistent. So you can do that one minus that one on top, provided it's that one minus that one on the bottom. But you could absolutely do it the other way around. People often get the sign wrong on the gradient. That's a very common mistake. If you're ever given the two coordinates, just quickly draw them because people often easily recognize a negative gradient compared to a positive gradient. But yeah, you're definitely going to be using that in this homework. You're definitely going to be using distance. And distance would just be given by the square root of how much y has changed squared plus how much x has changed squared. And you can do these subtractions either way around actually because you're squaring them. So I just look at the gap in the y's and square it, and the gap in the x's and square it. And then we'll probably end up using midpoint sometimes as well. And that's where you just add the x coordinates together and divide by 2 because you're finding the average. And you add the y coordinates together and divide by 2 because you're finding the average. Okay, without further ado, let's get on with the questions. Okay, gradient of dE, that's going to be minus 1 minus 0, which is just minus 1, over 0 minus minus 2, which becomes plus 2. And so that gradient is negative a half. Watch out, if you've got a half, you've made a sign error. I probably should write down what I'm doing there, just because it's 2 marks. I probably should have done minus 1 minus 0 over 0 minus minus 2, just to make it obvious, writing 0 plus 2 there, just to make it obvious what I'm doing. I always look at the marks to decide how much working I should do, but really you can do that in your head. Okay, find the equation of the line through F that goes through this point, parallel to DE, so it's got this gradient, the parallel gradients are the same, giving your answer in this form. Okay, so we're going to have y minus 3 is minus a half times by x minus 2, yeah? Now, what am I using there? I'm using y minus y1 is m times x minus x1. You might be wondering, why am I not using y equals mx plus c? You absolutely can use y equals mx plus c, but when you've got to write it in this form where those are integers, this way is honestly quicker, and that's why I'm choosing not to do it that way. You can do it that way, but if you do it that way, be careful that, well, make sure you find c correctly. What I'm going to do now is I'm going to double everything, just because I've got a minus half there. That leaves a minus outside these brackets. I've just got to double the half. And so 2y minus 6 is minus x plus 2. And now if I put it all on one side, I get 2y plus x minus 8 is 0. Yes, that is absolutely the same as minus 2y minus x plus 8 equals 0. Both of these answers are correct because you can times it by minus 1 and it doesn't make it any different. You've just times every term by minus 1. It's still exactly the same answer. Okay, by calculating the gradient of EF, show that DEF is a right angled triangle. So EF gradient, I'm going to write it like this, M little e f. EF's gradient is going to be, once again, change in y, so 3 minus minus 1, that becomes 3 plus 1, over 2 minus 0, so that's 2. Gradient of EF is 2, and that's great because remember, the gradient of DE is up here, so M of DE was minus a half, and therefore we've got perpendicularity, because perpendicularity occurs when the gradients multiply to give minus 1. And in general, basically, m1 times m2 equals minus 1, then m1 and m2 are perpendicular. Now here we have mde times mef is minus a half times 2, which is minus 1. Another way of looking at this is one is the negative reciprocal of the other. And then you just need to say hence perpendicular, and so the triangle is right angled. So DEF, the right angled triangle. And you must write that at the end. You need a little conclusion. What's more, the right angle is at E because it's D to E and E to F. So the right angle must be at E. Calculate the length of DF. Draw a little picture. Coordinate geometry is really, often it's really useful to draw a little picture. So if I'm calculating the length of DF, because I've got a funny feeling this is going to have something to do with Pythagoras. Actually, no, to be honest, I've just suddenly had another thought. If I've got the points D and F, I think I don't even need the picture. I can just use my distance formula, which is here. I change my mind a lot when I'm doing maths, sorry about that. If I need to find the length of DF, I'm just going to do distance equals square root of. Now, I prefer to just do it like this. If I'm finding distance DF, I just look at how much Y has changed. It's changed by 3, and I square it. How much X has changed by 4, and I square it. The reason why it doesn't matter which way round I do the subtraction is because I'm going to square it afterwards. 3 squared plus 4 squared is 25, and therefore square root it, and you're going to get 5. That one probably you quite liked. It's not a bad one. Okay, question 2. Find the gradient of this line. Well, what have we got here? If we rearrange this into y equals mx plus c, we should be able to eyeball what we've got and just decide on the gradient. So I'm going to leave the 4x plus 5 on the right-hand side. I'm going to add the 3y over, then divide by 3 to give me that. And so y is 4/3 x plus 5/3. I can split the fraction like that, and therefore I know that the gradient is 4/3. Hopefully that one is nice and straightforward. Part 2, I've got to find the equation of the line L2. It goes through 1, 2, and it's perpendicular to L1. Okay, if it's perpendicular to L1, I'm just going to write down M perp, which just means perpendicular gradient. It's just my way of notating it. Now, I just take the negative reciprocal there, and the negative reciprocal of 4/3 is minus 3/4. That's to find me a perpendicular gradient. I've also got a point on the line, 1, 2. So what I can do now is I can just plug this into y equals mx plus c, or y minus y1 is m times x minus x1. I'm going to try and encourage you to use this formula because it is slightly easier, really. The y1 and the x1 stand for a point on the line. M stands for the gradient. So we get y minus 2 is minus 3/4 times by x minus 1. And then I simplify that, rearrange it. I'm going to times it all by 4, so 4y minus 8. I'm going to times a minus 3 into the brackets as well, minus 3x plus 3. And so I end up with 4y plus 3x minus 11 equals 0. And if you had minus 4y minus 3x plus 11 equals 0, that's also correct. Okay, part 3. The line L1, and that's the line I think we just found, is it not? Let's have a look. Oh, no, that is the very first line. This is L1. The line L1 crosses the x-axis of P, and the line L2 crosses the y-axis of Q. Find the coordinates of the midpoint PQ. So a little bit of work to do here. For L1, if it crosses the x-axis, that's where y equals 0. And if y equals 0 in this equation, you're going to have a big 0 there. And so you're going to get 4x plus 5 equals 0. And so x is going to be minus 5 over 4. And that's where it crosses the x-axis. So let's write that down. L2 crosses the y-axis at Q. So that's where x is 0. And I'm going to go to L2's equation, which is down there. Just do that over for you. There's L2's equation. I'm going to plug in x is 0. So I get 4y is 11, and therefore y is 11 over 4. So the coordinate here is 0, 11 over 4. That is your Q. That is your P. And I need the midpoint of PQ. And the midpoint, therefore, is going to be, add the x's together, divide by 2. And 0 plus minus 5 over 4 is minus 5 over 4 divided by 5 over 2. Divided by 2, you get minus 5 over 8. Add these two together and divide by 2, you get 11 over 8. And hopefully I've got it right. Yeah. I've got the mark scheme in my hands, by the way, so I'm just checking my answers at the end because everybody makes mistakes, yeah? You'll notice as well, the skills in these questions really are doing multi-step problems, doing a series of steps. Okay, calculate the length PQ, given your form, answer in the form A root B. So the length of P to Q is going to be the distance from this one to this one. And if you remember, distance is a square root of how much x has changed squared. Well, that's going to be 5 over 4 squared. I can put the minus in there, but I'm going to square in a second, so that's going to disappear. Plus 11 over 4 squared. That's going to give me, you're going to get 25 on the top of this one, 121 on the top of that one, and 121 plus 25 is going to be 146. And then you're going to get 16 on the bottom there. But you can square root 16, and so you get 4 on the bottom, and then you're going to get root 146 on the top. I've left it in the format they wanted me to leave it in. Okay, let's go on to question 3. Okay, the points A and B have coordinates minus 5, 2 and 3, 1 respectively. Find the equation of the line AB, giving your answer in this form. Well, the gradient of AB, we always need a gradient at a point on the line really. It's going to be 1 minus minus 2, which is 1 plus 2, over 3 minus minus 5, which is 3 plus 5. And so that's 3/8. Once again, let's actually use y minus y1 is m times x minus x1. When I first started teaching here, I never used to use this formula really. I just used to use y equals mx plus c. There's not really much difference in it, but I do find it slightly more convenient now to use this formula. So that's the reason why I'm using it throughout. Equals 3/8 times by x minus 3, times it all by 8, times the 3 into the brackets. And then you've got the answer as 8y minus 3x is going to be, now you're going to add that on, so it's going to be plus 1 equals 0. Yep, cool, I've got the same answer as that. Remember, if you've got minus 8y plus 3x minus 1 equals 0, it's the same answer and it's correct. Find the coordinates of the midpoint of AB. Well, that's going to be midpoint equals, we're just going to add the x's together, which gives me minus 2, and then divide it by 2, which is going to give me minus 1 eventually. And then we're going to add the y coordinates together. 1 plus minus 2 is going to be minus 1 divided by 2. And so you get minus 1 minus a half. I do like pointing out though, you know, you're just finding the middle of minus 5 and 3. Obviously it's minus 1. You're just finding the middle of minus 2 and 1. Obviously it's minus a half, and that's why that's the midpoint. Okay, let's do part 3 now. Calculate the length of AC. So let's write down A's coordinates nice and clear, and C's coordinates, that's up here, minus 3, 4. If I'm finding the length of that, it's just the old distance formula again. So change in y is 6, square it. Change in x is 2, square it, and you get root 40. You could simplify that because that's actually got a square factor of 4, which you can square root. So it's the same as 4 times 10, but you can square root the 4, giving you 2 root 10. Hopefully I've got that one right. Yeah, I have. I'm occasionally looking over at the answers and checking. Determine whether the line AC is perpendicular to line BC, showing all your working. Well, let's find the gradient of AC. The gradient of AC, have we already found that yet? No. Okay, so the gradient of AC, well, this is A and this is C. The gradient's going to be 4 minus minus 2, which is 6, and then minus 3 minus minus 5, which is minus 3 plus 5, which is 2. So that gradient is 3. The gradient of BC, well, that's where we're using 3, 1 and minus 3, 4. And so that's going to be 1 minus 4, which is minus 3. And then 3 minus minus 3, which is 3 plus 3, which is 6. And that's minus a half. So it looks to me like they're not perpendicular, because one is not the negative reciprocal of the other. But another way of putting it, and you must justify your answer, you know, I'm just going to say as 3 times minus a half doesn't equal minus 1. Remember, two perpendicular gradients you multiply to give minus 1. Okay, let's try number 4. Number 4, we have A is the point 27 and B is the point minus 1, 2. Find the equation of the line through A parallel to this, so I know its gradient is 4. And they want us in the form y equals mx plus c. Maybe I'll use y equals mx plus c this time then, just for changing it up a bit. Okay, so it goes through A, so A lies on the line. So I'm just going to write it as y equals 4x plus c. And then I just plug in A. 7 equals 2 times 4, which is 8 plus c. So c is clearly minus 1. So we get y equals 4x minus 1. And it was easier to do it like that because they wanted it in this format at the end, so it seemed sensible to do it like that. Calculate the length of AB, giving your answer as a simplified third. Well, this is just going to be distance equals, now like I say, I try not to faff around too much here. How much is y changed there? 9. Square it. How much is x changed going from here to here? 3. Square it. So that's root 90, but that's definitely got a square factor of 9. 10 has no square factors. So I could say that's 3 root 10. Okay, find the equation of the line of the perpendicular bisector of AB. So if you need a perpendicular bisector of AB, well, that's like you need the midpoint then, and you need the gradient to find the perpendicular gradient, because the perpendicular bisector should go through the midpoint and should be at right angles to the original line. If you see what I mean, that's a perpendicular bisector. So firstly, let's find the midpoint. And the midpoint is middle of 2 and minus 1 is going to be a half. I hope you don't mind me doing this bit quite casually because there's a lot of work to do here. Middle of 2 and minus 1 is a half. Middle of 7 and minus 2, well, that's a gap of 9. So if I add 4.5 to minus 2, I get 2.5 or 5 over 2. So I've got a point which lies on my perpendicular bisector, which is good. Now the gradient of AB, that's going to be change in y, which is, well, if you like, minus 2 minus 7, which is minus 9, over minus 1 minus minus 2, which is minus 1. Sorry, did I say minus 1 minus minus 2 there? Let's do it again. I did minus 2 minus 7, which is minus 9, and then minus 1 minus 2, which is minus 3. And so I get a gradient of 3. It never hurts to actually draw the points on a quick sketch so you can get the sign right. Therefore, the perpendicular gradient is going to be minus a third. So now I can use my y minus y1 is negative a third times by x minus x1. But I can plug in my point on the line. So I get y minus 5 over 2 is minus a third times by x minus a half. Times it all by 3 is, actually times it all by 6 because we've got halves and thirds here. If you times it all by 6, it's going to get rid of a lot of the pain. Times that by 6, and you've got 6 over 2, which is 3, so that becomes minus 15, yeah? Times that by 6, you're going to get minus 2 times by x minus a half. But in a minute, all the fractions are going to disappear because we're going to get 6y minus 15 is minus 2x plus 1. Watch for the signs. So 6y plus 2x, and that's going to be minus 16 equals 0. I'd like to simplify that because I can halve every digit, and I get 3y plus x minus 8 equals 0. Remember, you can have the signs all the other way around there, but that is correct. Cool. Number 5, we're getting there. Number 5. Okay, A, B, and C have these coordinates. This is probably the kind of question, actually, which starts, this is one more difficult question, so I can see it straight away. It looks harder. Given that the distance between the points A and B is twice the distance between the points A and C, calculate the possible values of P. Okay, we could use the distance formula here. Another way we can do it with vectors, actually. I'm thinking straight away, you could do this with vectors, but I think they wanted you to use the distance formula, so that's what I'm going to do. Okay, let's find the distance between A and B. I'll call this distance of A and B, so dab. Okay, that's going to be the square root of, okay, 7 minus 1, which is 6 squared, plus P minus 5 squared, yeah? And I'll just leave it like that for the moment. Now, that's twice the distance between the points A and C. So let's work out the general distance between the points A and C. Now, the distance between the points A and C is going to be the square root of, okay, change in Y is 1, change in X is 3. And so we're going to get root 10 here. Okay, now let's read this very carefully now. Now, A and B is twice the distance of AC. So if I take the distance AC and double it, that should equal the distance from A to B, which is root of 36 plus P minus 5 squared. Okay, I think what I'm going to do here is I'm going to square both sides. That will give me, if I square that, I get a 4. If I square that, I get a 10. And 4 times 10 is 40. And if I square this, I get 36 plus P minus 5 squared. Okay, look at this equation. P minus 5 squared must be 4. That's because I need a 4 here for the equation to be true. So P minus 5 squared equals 4. Okay, I can now square root that, but remember when you square root, you get 2 or minus 2. And then you can just add on the 5 to get P is 7, or add on 5 to minus 2, you get 3. And I'm going to check it, and yep, it's correct. I bet some of you squared out the brackets there and ended up with a quadratic and solved it. And you might have got it right doing it like that, but always look for shortcuts. I'm a big fan of shortcuts in life. I don't like doing things a hard way. Okay, given also that the line is passing through A and B has this equation, find the coordinates. Oh, given also, so we can use P as 7 or 3, which is interesting. The line passing through AB has that equation. Okay, right, let's actually work with that. So what they're telling me there is that the gradient of AB is 3. And the way I work out the gradient is by doing 7 minus 1 over P minus 5 equals 3. And if you just look at this, remember that we've only got 2 possible values of P. We're going to get 6 on the top here. And so we want 2 on the bottom. So this implies that P must be 7. Yeah, I'm not a big fan of like faffing around with algebra if I can just kind of look at it by inspection and work it out. Apologies if I'm skipping steps though and you don't like it. But can you see that P must be 7 here because you're going to get 6 on the top and 6 divided by 2 is 3. So P must be 7. So they're just telling you to exclude 3 here. Find the coordinates of the midpoint of AB. Well, now we know it's 5, 1 and 7 and 7, 7. And so the midpoint is going to be the middle of the x's, the middle of the y's. That's a gap of 6. Add on 3 to 1, you get 4. Midpoint 6, 4. Okay, right, last one, the modeling question. I've never been a big fan of modeling questions. To be honest with you, if you want to see what maths is really useful in life, well, it's the modeling questions which demonstrate this. So you should like the modeling questions if you're always moaning, what are we ever doing this for and why do we use maths? I personally enjoy the beauty of maths without the modeling. And so the modeling puts on extra layers of complexity, but we have to do it. So let's man up and have a go at this, or woman up, or whatever we're saying nowadays. Calculate the gradient of the line of best fit. Okay, I'm going to take this line of best fit. Now, these are, this is why I don't like it, because you get ugly numbers. You always get ugly numbers in modeling. It's just the way it is. You're better off in many ways making your triangle as big as possible. If we start from there and go all the way up to here, what are we getting here? Now, they're both in the millions of tons, so I can kind of ignore like the millions and just use the actual values on the diagram. Now, where's that? 30,000, 35,000. That looks like 36,000 going from 0, 36,000 up. And then if we're going from there, 500 to 1,000, I can barely read the scale. It's really hard, isn't it? That's about 900 up to 4,500. I make that 3,600. 900, I'm just checking that, up to 4,500, 3,600. And so I guess that that's a gradient of 10. There we go. That's a gradient of the line of best fit. Formulate a linear model linking oil production and carbon dioxide emissions, giving the relationship in the form C equals A plus PB. Well, we can see it's definitely C equals 10P plus B straight away. And I guess we need to work out B by picking a point on this line so we can work out the y-intercept. Yeah, I'm going to use the point which passes through. We can see that when we've got y as 0 here, we've got x as 900, or I'm talking about y and x, but I should be talking about C and P here actually. Now C is on P is on the x-axis, C is on the y-axis. So in other words, when C is 0, P is 900. And so we're going to get 0 equals 9,000 plus B. So B is minus 9,000. And so we get C equals 10P minus 9,000. Yeah. And that works it out for you. Can I point out as well that here, like, we're dealing with C and P, which are in the millions of tons. They're already in the millions of tons. And also there's tolerance in these kind of questions. So if you haven't got exactly 10, say you got 9.95 or something like that, that's fine. They accept that. They absolutely accept that. Now they want us to interpret the value of A in our model here. Now, what is the value of A? It is the gradient, which is the rate of change. Yeah, gradients are always rates of change. Students find this quite difficult. I'm not surprised. It is difficult. What does it mean, the rate of change in this? Well, what this 10 is really telling us is that for every time P changes by 1, C changes by 10. So for every extra millions of tons of oil production, you get 10 million more tons of CO2. For every extra, that's a rate of change. 1 million tons of oil production, and they want you to relate it to the context of the question here. You get 10 million tons of CO2. Where did I put it? Is it down there? My chemistry is awful. Okay, it's been too long since I studied chemistry. CO, I was going to write as CO squared there. With reference to B, comment on the validity of the model for small values of P. Well, the model definitely doesn't look valid because, once you've got, like, say, 500 million tons of oil production, it's suggesting that takes carbon dioxide out of the atmosphere because you have a negative amount of carbon dioxide emissions. That makes no sense, yeah? So unreliable, as we have carbon dioxide reduction for positive oil production. Carbon dioxide reduction for small values of P. And that's because we've assumed that this is a linear relationship. And that's not necessarily the case. Why doesn't the curve go something like that? Yeah, why isn't it exponential, in other words? We've just assumed it's a linear relationship here when we've done this. And that's the weakness of mathematical modeling. Never let somebody tell you that mathematical modeling is perfect. It's not perfect. And you should thoroughly understand the weaknesses of any mathematical model you put on things. It'll be pretty much like saying, oh, I've worked out that people grow an extra 5 or 10 centimeters every year when they're like 7, 8, 9, and 10 years old. And I'm going to decide, extrapolate from that, and look at how tall people will be when they're 80. Oh, they're like 8 meters tall. Obviously, that doesn't work like that. You have different things happening, and they're not all linear relationships. Use your model to predict the carbon dioxide emissions if you've got, now let me read this number right, 6 billion tons of oil was produced. Well, that means that P is 6,000. Watch out for that. That's easily, because this P is already in the millions of tons, you've got to set P equal to 6,000. And therefore, you're just doing C equals 6,000 times by 10 minus 9,000. And so that's 6,000 minus 60,000 minus 9,000, which is 51,000 million tons. And if you want to be clever and write it the right way at the end, that is actually 51 billion tons. A lot of CO2. There we go. And that is the end of this little presentation showing you how to do that homework. I hope it was useful. Come and see me if you're stuck with anything, or anybody else in the maths department. We're always here to help. All the best and keep up the hard work. Bye bye.